Okay, this is quadratic formula question. By the way, I think 24 actually will factor. Some will solve multiple ways pretty easily. Remember, a, b, and c are your coefficients of your x squared, x, and your constant when your equation equals 0. Make sure you've got it equal to 0 before you do this. That's a 1x squared, it's a negative 8x, and it is a 12 as the constants. Those are our values. So we take the opposite of b, that's going to be positive 8, plus or minus b squared, that's negative 8 squared. Remember, when you square anything, it'll be a positive. Minus 4 times the a value of 1 times the c value of 12, okay? All over 2 times the a value, which is 2 times 1. It's all order of operations from here. Just got to be very careful. 8 plus or minus the square root. Negative 8 squared is positive 64. Negative 4 times 1 times 12, that's negative 48. Really got to watch your signs. All of it's divided by 2. Okay, 64 minus 48, that's going to be 16, right? Which is a perfect square. So square root of 16 is just 4. So we have 8 plus or minus 4 all divided by 2. So remember, you're going to get two answers. 8 plus 4 is 12. Divide by 2, you get 6. 8 minus 4 is 4. Divide by 2, you get 2. So 6 and 2 are two answers. And I think if you factored that, that'd be the quantity x minus 2 times the quantity x minus 6, right? So could have gotten it that way too. Much faster. Factoring is much faster if the numbers are small. But not everything factors, okay? And this is probably one of those. So in this case, a is 3, b is negative 6, c is 2. Okay, we take the opposite of b, so that's going to be positive 6 plus or minus the square root of b squared minus 4 times the a value times the c value all over 2 times the a value. Okay, let's start simplifying it. 6 plus or minus the square root, that's going to be 36. Get negative 4 times 3, it's negative 12, times 2 is negative 24. That's going to be a 12 under the square root, and then it's all over 6. Okay, this one breaks down. Okay, square root of 12 is the square root of 4 times the square root of 3, right, which is 2 radical 3. So it's going to be 6 plus or minus 2 radical 3 all over 6, okay? Remember, your third grade teacher will want you to see if there's a greatest common factor. We have three terms here, a 6, a 2 radical 3, and a 6. Notice 2 divides into all of them. So divide everything by 2. That's going to give you 3 plus or minus 1 radical 3 all over 3, okay? As a decimal, you're taking 3 plus the square root of 3, get an answer. That whole thing gets divided by 3. To 3 decimal places, it's approximately 1.577. And then you're going to take 3 and you're going to subtract the square root of 3. And again, get an answer, then divide that by 3, and it looks like you're going to get approximately 0.423 if you round to 3 decimal places. Okay? Again, ACT, this is going to be the answer they're going to have. But if you put it in your calculator, that's what you should get. By the way, check that. Make sure you're getting the order of operations right on that. Okay, the discriminant. How to use the discriminant to determine the number of unique solutions. Remember, the discriminant is the b squared minus 4ac part. And so if b squared minus 4ac is negative, in other words, if it's less than 0, that's going to be no real solutions, right? If b squared minus 4ac is 0, that means you've got a 0 under the square root, which means when you add or subtract to 0, you're going to get the same thing. So you're only going to get one unique answer. So we'll call that one unique solution. And then obviously if b squared minus 4ac is anything greater than 0, you're going to get 2 real solutions. Okay, so let's try this with 5x squared minus 4x plus 6. A is 5, b is negative 4, and c is 6. So b squared minus 4ac, let's find out what it is. B squared, that's going to be negative 4 squared minus 4 times the a value of 5 times the c value of 6, okay? Remember, a negative squared is still a positive. It's going to be 16 minus, I can already see, let's see, that's going to be 20 times 6, which is 120. That's going to be negative, so that's no real solutions. Okay, last question, application problem. Frog jumping off a wall, it's a quadratic equation. The height after a certain time. So what's the height 1 second after it jumped? Well, That's just t equals 1, right? So we can sub t in here. It's going to be negative 16 times 1 squared plus 20 times 1 plus 4. So that's going to be negative 16 plus 20 is 4. 4 plus 4 is 8. And the height is in feet, right? So 8 feet above the ground. Part 2, how high is the wall the frog jumped from? Well, when it's on the wall, that's at 0 seconds, right? So we're putting 0 into our function. And if we put 0 into the function, that's negative 16 times 0 squared plus 20 times 0 plus 4. So it looks like the wall is 4 feet high before the frog jumps at 0 seconds. When does the frog reach its maximum height? What is that height? Well, this is an upside down graph, right? It's a parabola. You've got a negative 16t squared here, so it's going to be an upside down parabola. That's going to occur at the vertex, and we know that the vertex is negative b over 2a. Now, normally that's the x coordinate. They're using a t instead of an x here, but remember, that's the input variable. You've got two coordinates. You've got an x and a y, or I guess in this case a t and an h. So for the formula here, negative b is going to be negative 20 over 2 times the a value, 2 times negative 16. Okay, this is not going to be a whole number, is it? It's going to be negative 20 divided by negative 32. It looks like it's going to be at 0.625 seconds. That's interesting. Huh. Okay, what's that maximum height? Well, we can substitute that back into the function. Tell you what, we'll take a look at that height in just a second. Okay, last part here. After how many seconds will the frog land? Well, again, if you make a sketch of what's happening here, the frog's jumping off this 4-foot wall and it lands. What do you know about the function at the point when it lands? The height would be 0. Okay, so you can set the height equal to 0 in the formula you're trying to find at the time. So 0 is equal to negative 16t squared plus 20t plus 4. Okay, and I don't know, you might be able to factor, like you could get the numbers lower by dividing everything by 4, but I think this is just a quadratic formula and we need to put it in and be done with it. So A is going to be negative 16 and B is going to be 20 and C is going to be 4. So the formula, of course, is x equals negative b plus or minus the square root of b squared minus 4 times the a value of negative 16 times the c value of 4 all over 2 times the a value of negative 16. Let's work this out. All right. A negative times a negative is going to be a positive, so that's going to be 4 times 4 times 16. I think it's going to be 256, yeah. It's going to be 256 plus 20 squared, which is 400. So that's 656. I don't think that's not a perfect square, I don't think. No, it's not. Okay, so basically at this point, we're going to get a decimal answer here. Let's see, it's going to be the square root of, let's see, again, that's 400. I just want to verify that I have this right before I... Yeah, so it's going to be negative 20 plus or minus the square root of 656 all over negative 32 if we multiply this out. Okay, so I'm going to take negative 20 and I'm going to add the square root of 656. Okay, get an answer. Divide that by negative 32. That's interesting. So my first answer is negative, okay? I think what's happening, I think if this had continued before the frog jumped, hypothetically, this is back here. That's before the problem started, so that has nothing to do with this problem. It's not part of the domain. Let's try the second one, negative 20 minus the square root of 656. And that should give us a negative on top, and when we divide by a negative on the bottom, yeah, we're going to get approximately t is 1.425 seconds. That's our final answer there. Okay, so that's what's going on. Real quick here, let's check this. I'm going to make a graph on my graphing calculator just to kind of analyze this. Let's see what we've got going on here. So I'm going to put this function into my calculator. It's negative 16t squared. I'm going to have to use an x instead of a t, plus 20x plus 4, okay? And this is not going to last very long. I'm going to change my window here. This frog is hopping very quickly, so my x doesn't need to be negative. I'm going to change my minimum to 0. And actually, this is over in well under 5 seconds, okay? And I'm not sure how high he's going to jump, so he's not going to have a negative height, so I'm going to start my y minimum at 0. And let's say he could jump 20 feet high. We know he's starting 4 feet off the ground. So you may have to adjust your window a little bit. Okay, here's our frog jumping. And remember, we think that the vertex is at this point here. We think that's only 0.625 seconds, okay? I'm going to go run a table here and just check. I'm going to go to 0.625 on my table. And, okay, if you put 0.625 into this function, you get a height of 10.25. So at 0.625 seconds, we have a height of 10.25 feet. Okay, so the vertex would be at the point 0.625, comma 10.25. And of course, the 0.625 is the time. The height is 10.25. So hopefully that helps give you a little bit of background, whether or not you're substituting into the function, setting the function equal to a value, or using the vertex formula to find maybe a high point or a low point of a parabola. Those are really the main applications that I can ask you to do with a parabolic function.